Hi everyone, welcome back to session 14, Errorless Discrimination and Transfer Stimulus Control. One of the things we oftentimes ask ourselves is, in terms of effective teaching, what are the best ways to teach? What are the tools that are available to us? And one of the things that we have to recognize is that in terms of setting up a good learning environment for anybody, we do so when the conditions are optimal, in which we provide maximum reinforcement for an individual who is doing well and minimize the number of errors that an individual might make. And how we come to actually make the environment more reinforcing by increasing correct responses and less punitive by decreasing a lot of the incorrect responses, it's to our advantage to figure out how we go about arranging those things to take place. Most of us know that the things that we do well, we get reinforced for doing well. And in fact, the things that we get reinforced for doing well, we oftentimes say we actually enjoy. If we are constantly making errors in the things that we are doing, we may plug away and do it, but we might not have a whole lot of joy doing those sorts of things. In other words, this is certainly true of cooking, for example. When a person is learning to cook, the more successes you have, the more things actually come out, the better. When things continually don't come out very well, when they continually get burned, and I could tell you, at least with my wife tells me, is that baking in Colorado really is a challenge because of the difference in the elevation and so forth and so on. So again, some of your successes or failures are going to determine, am I going to keep plugging away at this until I, learn how to do it right? Now it turns out is that when you follow directions, recipes come out really well. It increases the probability of successes. It decreases the probability of failures. So in thinking about this, how well a person does in terms of learning something depends on the training manual as well. I'm hoping, for example, that as you learn this course, that you will come to enjoy it because the frequency of reinforcement is far greater in terms of obtaining correct responses than incorrect responses. And I'm hoping that the way that I've arranged my training, the way that I've arranged my material and so forth, optimizes your success. And in doing so, we hope that we will have more effective behavior analysts. At the very least, we hope that you continue to enjoy behavior analysis enough to get you through the next couple of courses. All this comes down to the notion of errorless discrimination. This is a procedure that Herb Terrace had utilized back in 1962, and that almost always in the behavioral tools that we use, or our textbooks and so forth, you will see some degree of errorless discrimination in the way some of the training manuals have been arranged. That is, if the behavior analyst who was writing the behavior manual really did their homework in terms of how to present stimuli. Okay, so I'm going to go ahead and freeze this and go through this procedure. Hang on a second here. Okay, and get my arrow going and get my full screen up here. And let me go through this procedure with you. Now, I mentioned to you, we usually do single subject design in the experimental analysis of behavior, but this is going to be one of several studies in which was a group design procedure. Now, this is a little bit cumbersome to go through, but you'll get the idea very quickly on how Terrace actually arranged this. There were 16 pigeons, and he took these 16 pigeons and assigned 4 pigeons to each group. And he went through training all 16 pigeons in the following way. In the presence of a red key light, which Terrace called S+, but or it's as SD, on the average, the first response after 1 minute produced grain to the pigeon. Okay, so all pigeons had this initial training, all 16 pigeons. Then he introduced a second stimulus, which was going to be an extinction stimulus, which is going to be a green key light, or as he called it, S-. But in fact, S- and S delta are one and the same in this situation. And he simply would alternate between reinforcement condition and extinction condition every 3 minutes. So when these experiments started, for the first 3 minutes, a red key light might be on, and it would indicate VI 1 minute. Then after 3 minutes, the conditions would switch, and now the key would turn green, which would indicate that extinction is in place. Now, what was interesting to Terrace was is that if these are successful responses that lead to reinforcement, then therefore any key pecking that occurs to green are unsuccessful, and in some instances, wasted responding. That is, it really does not pay to make a response over and over again when all you're going to be met with is extinction. But what he was interested in is how do you get an animal to learn not to respond to S delta? How do you get somebody to minimize these responses? And we would be asking the same sorts of questions that when a person is learning, we want to maximize successful responses, but if they're going to respond to situations where there are no reinforcers, how can we minimize that so they spend more time optimizing their reinforcers? Okay. If we're teaching somebody how to get a job, there are many places to get a job. We would want to make sure they go to places where they're more likely to get a successful job and actually get employment. If we find that our son and daughter are spending time looking at the help wanted ads in a particular section, and every time they call up and try to get a job or set up an interview, they're getting absolutely nothing. Over a period of time, that's sort of like a green key extinction procedure. We would hope that it's time for them to stop looking at this place, come back over here where they're more likely to get a job. Okay? So what we always are wanting to know in these situations is how to maximize responding in the presence of an SD, and when there's an extinction in place, how do we teach a person, don't waste your time responding to something that's not going to pay off in reinforcement. Now, of course, what Terrace looked at here is the way in which you introduce extinction makes all the difference in the world, and that's the lesson to be learned in this particular session. Terrace used 4 different procedures, and each group of pigeons had a different procedure. For the first 4 pigeons, they were in a group called the late constant condition, and this is the method in which we introduce extinction for all 4 groups. So for group number 1, late constant pigeons, what they went through was actually 15 sessions, day after day after day, 1-hour sessions of pecking and only responding to a red key. In other words, if we go back to the initial training, okay, for the late constant birds, they saw 15 sessions of nothing more than a red key light, pecking a red key light day after day after day, and getting reinforced on their variable interval 1-minute schedule. After 15 days or 15 full sessions of seeing and pecking red key light, Terrace introduces the green key. And the way this worked was that the session would start off on session 16. A red key light was in place. It was in place for 3 minutes, which was essentially variable interval, right? And then after 3 minutes, the light changed from red to green, and that green key was lit at its full intensity. It's just like a bright green key in the pigeon's face for a full 3 minutes, and after 3 minutes, the light changed back to red. And after 3 minutes of that, changed to green, red, green, and that's the way it was for session 16, 17, 18, and so forth and so on. So what happens here is that, again, the pigeon only sees and pecks a red key, and then all of a sudden, out of clear blue at session 16, they see for the first time a green key light, which is extinction. Okay? The second group of pigeons were called the early constant condition, and they too got the initial training of variable interval 1 minute, but on the very first session, when that pigeon started learning that red was associated with food, they switched back and forth 3 minutes red, 3 minutes green, 3 minutes red, 3 minutes green. In other words, it was at full intensity, switching from red to green to red to green. But instead of waiting 16 sessions of learning red and then all of a sudden seeing green, now on the very first session, they get the discrimination training going on at the very, very beginning. Okay? And again, what this shows you is that late just refers to how late in the history of running sessions did they first learn and come in contact with extinction. These pigeons, very late in their training. These pigeons, very early on day one in their training. Group number 3 were called the late progressive pigeons. So we got 4 pigeons in another group. And like the late constant group, the group of late progressives also were shaped up under VI 1 minute, red key light for food, for 15 sessions. And then on the 16th session, I got to explain this very carefully. At that point, Terrace introduced the green stimulus, okay? But what he did was, on the very first time after 3 minutes on red, he switched it to green, but the actual green key light was not full intensity like it is up here. And I tried to simulate this, by the way. I hope this comes through. This green, darker green, and darker green. This is just showing you something, what we call fading the stimulus. I'm fading the color of the word green, or the green color across these things. So I'm going from a gradual light green to a darker green. This is sort of simulating exactly what Terrace did across sessions 16 through 20. That is, red key was on, and then for 3 minutes it switched to green, except that it was only dimly lit, and it was lit for literally about 2 seconds, and then it went completely, the key went dark. So the pigeon, again, under this condition, is pecking a key for 15 sessions of red key light, getting food. On session 16, it starts off in this red condition for 3 minutes and then switches to extinction. However, the extinction key is not on for the full 3 minutes. It's only on for about 2 seconds. It looks less intense, like this, and then after 2 seconds, the key goes completely dark and stays dark for the rest of the 3 minutes. When the 3 minutes is up, it switches back to red. And now we're back into the VI 1 minute. And the pigeon's pecking and getting food, and everything's great for 3 minutes. 3 minutes is up, switches back to green, but now we make the color of the green key a little bit more intense. We turn up the intensity of the light, and instead of keeping it lit for 2 seconds, we keep it lit for about 8 or 9 seconds. And then the key goes dark again and stays dark for 3 minutes. Then after 3 minutes, it goes back to red. VI 1 minute is in effect. Food is available for 3 minutes. And then it switches back over to green again. And in this situation, the intensity of the stimulus is turned up so that it's a little bit brighter. And now it's on for about 20 seconds. And essentially, we are gradually, each time we come back to the green condition, we are making the key color a little bit more intense in terms of its brightness, and we're keeping it lit for a longer period of time, so that by session 17, 18, and 19, after going through this procedure, we're up to the point at which now it's at full intensity. This defines what we call the progressive condition. That is, we are progressively changing the stimulus from dim green to bright intense green, and we are gradually, progressively changing the duration of the key being lit for very brief durations to longer durations. Hence, when we talk about the constant condition, that indicates that when we introduced the extinction procedure, it was constant. It was at full intensity and on for the full 3 minutes. This procedure that we're talking about here is what we call fading. It's we actually take a stimulus and gradually change the physical properties of the stimulus without disruption of stimulus control. Finally, group number 4, early progressive. Same as group 3 in terms of they too were exposed to the extinction key in this same process, this progressive process of going from dim, lit for only 2 seconds, to dark, intense color, like it is up here, lit for the full 3 minutes, but it's gradually changed across trials and across sessions, okay? And it actually takes about 5 sessions to actually conduct this. And again, it's early in their training. So up here, this happened after session 16 or 15. This happens, whole process happens, to recap, 4 groups of pigeons. All of them got reinforced for pecking red at full intensity, VI reinforcement. All groups of pigeons were exposed here to extinction, but each group of pigeons were exposed to extinction in 4 different manners. Constant versus progressive, early versus late. I hope that makes sense. See, I know it's a little bit cumbersome, but it's important to go through this procedure, and then we'll go through the results. Again, fading is a situation in which the property of a stimulus, in this experiment, the intensity of the green light and the duration at which it was lit, is gradually changed on successive trials, okay, from one stimulus property to another. In this situation, if we're talking about errors were defined as any PECs to the green extinction key. Now, we want to note here that to obtain what's called errorless discrimination, we must start with a discrimination that already exists, and then change the stimulus gradually. Now, here I have to mention to you that we cheat a little bit. If your goal here is to get a pigeon to not respond to extinction, in other words, when a green key color comes up, you don't want them to peck the key. In other words, peck red, don't peck green. That's the rule. And if they peck red and continue to peck green, they're making errors, even though the instruction says, peck this, not that. This is food, that is not food. That's why he defined pecks to green as errors. Okay? And if we have a whole lot of errors, we have a lot of mistakes. So it makes sense that we want to set up educational systems which maximize correct responses, but minimize the amount of errors an individual's making. I'm going to go through why this is so important, but the reason should be pretty obvious to most of you when we get to there. Okay? I want to point out that we start by making a discrimination in the sense that pigeons, and here's the hint, pigeons don't peck dark keys. Isn't that interesting? So that when we come back to this condition here, we note that when the progressive stimulus comes on and starts off at a very dim green, it's only on for 2 seconds in that 3-minute period, and then the light goes out and the key goes dark for 3 minutes. That's in session 16. And when the key is dark, you know what the pigeon does? Well, I'll tell you what the pigeon doesn't do. It doesn't peck a dark key. So what we are doing is we are going to transfer stimulus control from a dark key to a green key, right? And this is what the fading procedure involves. We know that when the key goes dark, the pigeon won't peck the key. How do you get that performance to take place when a green key light comes on? You gradually fade the stimulus control from the dark key in this manner. Go from gradual, lit only a short time, and gradually make it more intense and increase the duration in which that green key is actually available to peck. Okay? And when we do that, let me show you the results. These are the results from the late constant condition. Over here, you're looking at the number of responses to S minus. In other words, this is the frequency of errors. Key pecks to that green key. Where do you get your worst performance? Late constant, right? What is late constant? The group of pigeons who were pecking red for a long period of time, and then all of a sudden we introduce the discrimination procedure without taking consideration of how we introduce extinction. And under this condition where we just simply wait until the response is established after 15 sessions of pecking red, now you introduce a green key light and they just go literally nuts on that key. In other words, look at the number of errors that they're making here. We're talking in the neighborhood of 4,000 to 5,000 responses for all of these pigeons in this condition, right, in the presence of green and never getting food. That's a lot of errors and a lot of wasted behavior. Compare that to where we get the fewest number of errors, early progressive. Okay, and what does the early progressive consist of? It consists of 2 things. Number 1, gradually using the stimulus control procedure to transfer stimulus control from not pecking a dark key to pecking a green key, but noting here, it also helps to do it early in the procedure or early in the training, because look what happens. It's not that just the progression works, because look, even with the late progression, you're still getting errors into the thousands over here. Okay, so even though you're using the fading procedure, it's coming very late in the training history. And what we're probably seeing, generally speaking, is that if you are a hungry pigeon and you have been pecking red, bright things for a long period of time, you're going to have pretty strong generalization. So that the instant all of a sudden the conditions change from red to green, you've just been pecking bright things, so you just continue to go ahead and peck things that are bright. The longer you've been pecking it, the more reinforcement you've been pecking for red, the more intense, the more this behavior will be robust in terms of pecking the extinction key. Okay? You got to catch it early on, and you got to do it in this manner to actually minimize the number of errors. And of course, I presented some of the graphs here, which kind of show you again. You get most of the errors over here early into these procedures with these pigeons, and then all of a sudden, look how quickly extinction takes place. The responding drops out. Okay. Note the scales over here. Look at the early constant condition over here. They start off making errors over here into the hundreds, and they're still making over to here, even as far as 5 sessions into it. Don't know what's going on with this pigeon here. Kind of weird. In the late constant condition also, we see, again, a lot of errors. Lots and lots of errors over here. Okay. All right. So now we come back to the situation here of how to minimize errors and where we might actually find some utilization for these procedures. Now I'm going to actually try to do something here. I'm going to use the margins over here to demonstrate something to you in terms of discrimination training. Now I just learned how to use this. Let's see if this will actually work. I'm going to go from full screen to a short screen, and let's start off with the discrimination. I'm going to actually draw on this and start off with the discrimination that's oftentimes difficult to make. Little b, little d. Okay? It's not a perfect circle, but bear with me. It's the best that I could do. If we're teaching a child to do the verbal response B versus D, okay, actually let me go ahead and get rid of that little mark there, okay. So if I'm looking at B versus D, a child may make a lot of errors, B versus D, and they may call B D, call D B, and why? Look at how similar the stimuli are, okay. That is, the B looks just like the D in terms of the arrangement, sort of like a red key and a green key. I'm going to go ahead and clear this. And I'm going to show you a way in which you could actually teach a response, taking advantage of this errorless procedure. I could start off teaching a child, actually make this a little bit more. Okay. And I'm going to make this big B, and teach the child D, but I'm going to keep the stimuli very little. Okay? And now, if I go ahead and I tell the child, which is B, and I have them respond over here, they're responding to not only the arrangement of the stimuli, but the size of the stimulus. Okay? I might actually emphasize this, let's say, point to big B, and then the child points to big B, and I reinforce it, say, yes, that's big B. Look how big B is. Now come over here and point to little d. And the little child will come over here and point to little d, because we're taking advantage of a couple of stimuli here. My voice, we're taking advantage of the size differentiation, but mostly you got a child who's going to probably make this discrimination fairly rapidly with very high accuracy of correct responses and very few errors. And when you're actually able to get a discrimination between that stimulus and that stimulus, you're more likely to get a child who's encouraged to now go on to the next level of training, which we make big B a little bit smaller, and we make little d a little bit bigger. Okay? And now we might go back and forth between these two. And all we're really doing here is fading the stimulus control. The nice thing about this is that We have the capability of doing all of these kinds of things by arranging font sizes, thicknesses of line, and so forth to do these kinds of training procedures. Okay. Let me go over another thing that becomes pretty obvious from this. We talk about this in the experiment here with the picture. Let me see if I can get rid of the board here so I don't draw all over the figure here. Okay, we're obviously talking about pigeon behavior in this errorless discrimination procedure. But one thing that really strikes me as really important, actually, let me show you one thing here. I want you to be aware of something, just to show you that we got to be careful. When we talk about errorless learning, look at what our eyes are focused on. When I show you this graph and you're looking at errors, obviously your eye is drawn to this and saying, whoa, look at all those errors that occur in late constant. Quite frankly, that's the worst way to introduce an extinction procedure. Lots of errors, lots of incorrect responses. Don't do this. This is the worst possible scenario that we could do for teaching. Now, if that's true, and this is the worst, then obviously that must be the best. And if these are lots of errors here, it's tempted to call this errorless, but I want to point out something to you. Be careful. Note the scale here. We're still talking about errors here. This is not zero. This is not truly errorless. There are errors that occur during errorless discrimination training. So I do want to point out here that be careful when you look at graphs. Be careful when you look at the y-axis, the ordinate, to make sure, because it's very easy to see something here that's somewhat deceptive. There were errors here, but I do want to point out, although there were errors here that might have been in perhaps the 60s or 70s, that's a heck of a lot different than into the 4000s, 3000s, and 2000s. Okay, so that's the first thing I want to point out. The second thing I want to point out that makes sort of intuitive sense about this is that if we are going to teach discriminations to individuals, it makes perfectly good sense based on this research that the discrimination training should happen as early as possible in a person's life. Not to wait and wait and wait to teach, but to teach and teach well and teach early by providing ample reinforcement for correct responses and find ways to minimize errors by arranging the extinction or the S delta conditions so that it's easier to make these discriminations. Okay? To me, if we're going to make the grand leap from the pigeon to the human culture, this should be one of the most powerful arguments for early intervention, in the sense that if we are going to use our funding and use it well, get it in there early. Get these kids as early as possible. Find these things that work well and start teaching language as early as possible. The longer we wait to do these trainings, the more errors the person's going to make, because they're learning these discriminations and getting lots of reinforcement and being not having an opportunity to learn the discrimination procedures. Okay, so again, if we're going to do these procedures, a lot of times if we could get the funding in there early, it's going to raise the probability that we're going to get more effective teaching at an early age, rather than waiting and waiting and waiting and waiting until the person is 18 or 19 or 20, and then all of a sudden they change funding systems, and now we're going to start teaching them things that we should have been teaching them way back when they were much younger in terms of language acquisition. Okay. All right, and so that closes it for errorless discrimination, and we will come back and talk more about condition reinforcement and behavior acquisition shortly. Until then, I shall see you guys later, and study hard.